All right, let's run through a few of these problems where we're determining if a relation is a function or not. So, for the first one, we're looking to see, does each input, which are the x values, have one output? So in this case, each input is unique. There's no repeats, so this one is a function. As opposed to something like number 3, where if you look at all the x values, so all the inputs, we notice there's a repeat right here. The number 2 is repeated twice. The input is repeated. So each input does not have one output, which makes it not a function. So looking at problems 4, 5, and 6, 4 in the x column, so I'm looking at all the inputs, there are no repeats. So this one is a function. As opposed to number 6, if I look at the inputs, there's a repeat right here with -2. -2 has 2 different outputs, so this one is not a function. And we know with a graph, to determine if something's a function or not, I want to draw a vertical line through the graph. So if I were to draw a vertical line through number 7, I never cross more than one point at any given time. So no matter where I draw that line, it's never crossing more than once, so this is a function. Same with number 8. No matter where I draw a vertical line, it only crosses the graph once. So this one's also a function. As opposed to number 9, if I draw a vertical line, it crosses this graph twice, making it not a function. So that's how you decide if something is or is not a function. We also learned to evaluate a function. So what that means is I'm going to take what they're asking me to find, which is h of 6. That means 6 is my input value. That's what's going to go in for the variable to the function. So for this one, h of 6 is going to be equal to the absolute value. Instead of t, I'm going to put in 6, what they're asking me to find, and then evaluate. So I can write equals 6 plus 2 is 8. The absolute value of 8 is just 8. So it's 8 plus 3, which is 11. So the final answer for this one is h of 6 is equal to 11. Same thing if I move down to a problem like number 7. I'm going to be putting -8 in for x. So notice how whenever I plug in a number, I like to use parentheses around it so that I can see -8 is the number being squared. And for this one, there's 2 places where x is. So I have to put -8 in 2 different places. And again, I put them in using parentheses. So -8 squared is positive 64. And then -3, because the minus sign, times -8 is positive 24. So this will add up to be 88. So we would say f of -8 is equal to 88. And we read this to say that when the input was -8, the output was positive 88. And as you can see, we can also do this for variable expressions. So here, I'm going to plug in x plus 2 where the input is. So it's going to be h of x plus 2 equals 4 times x plus 2 minus 2. And then I'm just going to simplify. I'm going to distribute the 4 to get 4x plus 8 minus 2, which when I combine the like terms is 4x plus 6. So plugging in x plus 2 gets me an output of 4x plus 6. Final answer. And so another thing we learned about is determining the domain and range. So remember, domain are the set of x values, whereas range are the set of y values. And so my domain, if I look at all the x values, I like to use curly brackets here, is -5, comma 0, comma 2, comma 5, comma 3. Close it with curly brackets. Order doesn't matter. This does not need to be in numerical order. Range, I'm going to look at the y values. So it's going to be 7, 0, -8, -20, and -6. And so if I look at my inputs to determine if it's a function, each input had only one output. There were no repeats for my input values. So this one is a function. So for the next one, my domain is going to be -2, -1, 0. I'm not going to write -1 again because I already have it written once. You only write each number once. +2. And then my range are the y values, 1, 3, 5, 7, 9. And then I'm going to look at my input values to see if each input has one output. And here I see -1 matched with 3 and it matched with 7. So that makes it not a function. Here they want me to create a mapping diagram. So my input or my x values always go on the left and my y values always go on the right. So my input values are 2, 3, and -1. Same thing here. Order of these numbers doesn't have to go numerically. And then I'm going to put my output values here. No repeats though. So 5 shows up twice, but I'm only going to list it once. And then 3 as well. And then I just connect each input to its corresponding output with arrows. Now, to determine if it's a function, does each input have one output? The answer is yes. So this is a function because each input has one output. So these problems, similar to what we were just doing, they want to know, first of all, is it a function? So does each input have one output? The answer is no, because one has two different outputs. So this is not a function. My domain are the set of input values or the set of x values. Not going to repeat the one that shows up twice. And then my range are the set of y values. So -2, 0, 2, and 3 are my range values. Good. So is it a relation? Yes. Anytime you have a pairing of x and y values, it's automatically a relation. Domain are the set of x values. So I'm going to look through each of these points and determine the set of x values. So this first point has an x value of -2. This point has an x value of -1. Both of these points have x values of +1, and both of these x values have x coordinates of 3. Again, even though there's 2 points, I'm only going to write the input once. The range are the y values, so let's work through the points again. This has a y value of -2. This has a y value of 1. Y value of 1, so I'm not going to repeat that. 0 is the y value here. This has a y value of 3, and this has a y value of -2, but I already wrote that, so I'm done. And then remember, to determine if it's a function, I'm looking to see if I draw a vertical line, do I cross more than one point? And the answer is I do right here, so this one is not a function. So yes, automatically a relation because it's on a graph. No, not a function because it doesn't pass the vertical line test. So let's create a mapping diagram for number 9. Inputs go here, outputs go here. So my inputs are the x values, -2, 0, and 5. And my outputs are the y values, -1, 3, and 4. -2 matches with -1, 0 matches with 3, 5 matches with 4, and -2 matches with 3. So my domain are the x values, which we can kind of easily see in a mapping diagram, -2, 0, and 5. And the range are the y values. or the outputs, -1, 3, and 4. And then did each input have one output? No, because -2 has two outputs. So this one is not a function. Okay, this last one, finding domain and range, can be a little bit tricky. So I'm going to use two different colors to help us visualize it. Domain is how wide the graph is. So the widest it goes, it starts at -5, and then the widest x value it goes is 7. So from -5 to 7, this graph had x values. So my domain is -7, oh, sorry, not -7, -5. So from -5, the furthest left, and I'm going to write it like this, to +7. We write it as an inequality. So domain is how wide it goes. Range, let's use a different color pen, is how tall it goes. So the lowest is -9, the highest is +9, and it's everywhere in between. So we're going to write -9 less than or equal to y, because range are the y values, less than or equal to 9. And then lastly, my question is, does this pass the vertical line test? Can I draw a vertical line and only cross once? Yes, I can. So this is a function. Okay, let's do this graph. Domain is how wide it goes. So the widest it goes is -10. The furthest to the right it goes is +10. So we write it as an inequality with x in the middle for domain. And then we'll do the same thing for y. The highest it goes is 5. The lowest it goes is -5. So -5 less than or equal to y, less than or equal to 5. And then does it pass the vertical line test? Yes, because no matter where I draw a vertical line, it'll only cross once. Okay, last one. So domain is how wide? From -8 to +2. That's the width of this graph. And then the height, it goes from +8 down to -5. So from -5 to +8. And it passes the vertical line test, so it is a function.